Hello everyone, welcome to Coding Autos. So today we will see one question which is an application of Mozart. It is a count inversion problem. It is most famous question related to Mozart which will be asked in your interview questions. So we will look into it with an example. So let's consider an array having an element 5, 1, 3, 2, 4. Now when you apply merge sort on it, what you usually do is you divide an array into two halves. So when you divide it, it will be divided into 5, 1, 3. Then further it will be divided into 5, 1, then 5. Okay. And after dividing it into the smallest element possible, then we try merging it, and while merging it, we sort the arrays. So count inversion problem is also based on this approach, that whenever we are trying to merge them by sorting them, then it will perform swaps. Okay, so they are checking whether the elements in the first array is bigger or smaller than the elements in the second array. If it is so, we will swap them. Um, so count inversion problem is basically if an element earlier to the next element is bigger than that element, then we will increment the count by 1, which means that now we need to swap it because the further element is smaller than the earlier element, so we are swapping the elements now. So here when we have divided the elements to the smallest element possible, now we got smallest element which is 5, then it will again go back to its previous step. Now it will call its left recursive function, then it will merge it. So while merging, we will copy these 5 and 1 into separate arrays and we will compare them. Now the first array will contain 5 and the second array will contain 1. As the first array's element is bigger than the element in the second array, so here we got one condition that the further element is smaller than the earlier element. So here we will need to swap the element. So we will increment the count by 1. So after merging them, we are incrementing the count by 1, and then the previous function call, um, the flow of the program will return to the previous function, where from the left side we got and count as 1, and from the right side, as we only have 3, we are merging 1 5 with 3, and 3, as 3 is alone, we are simply returning it. It is not counting anything as no swaps are being performed. So 1 plus 0, uh, total one swap is there, and after we arrive at that position, we need to merge them. So while merging two sorted arrays, again the swapping will be performed. So for this, as 1 and 5 and 3 will be merged, so as 1 is less than 3, no swap will be performed. As 5 is more than 3, one swap will be performed, because the earlier array is bigger than the element in earlier array is bigger than the element in next array, so one swap will be performed over here. So that is why 1 plus 0 plus 1, this is 1, this is 0, and after merging we got one swap, so total two swaps are being performed. Now these two swaps are being performed in the left array, and the elements will be sorted, and in the right array, as you can see, we are merging. We will be returning it, and now this function will start 2 4 2 4 will be divided into 2. Now as 2 is the smallest element, it will return back 0 swaps will be performed. It will return back to 2 4. Now 2 4 will call the right one. Now the right element will perform 0 counts. Now while merging them, as 2 and 4 are 2 is less than 4, no swaps will be performed. So 0 0 swap, and after merging also 0 swap will be performed. So now what we need to do, we need to merge these two sorted arrays 1 3 5 and 2 4. Now here in the left subtree we got two um, two counts, in the right subtree we got 0 count. Now while merging 1 3 5 and 2 4, how many um, how many swaps will be performed? So let's see. 1 is less than 2, so no swap will be performed. Now the counter will point to 3. Okay, so 3 is more than 2, so we need to insert 2 inside our array. So what 2 will do is, 2 will, as
it is a sorted array, so as 2 is less than 3 it will also be less than 5. So what we will do, we will add 2 over here, okay, because we don't need to calculate it separately for 3 and 5. We simply put all the length of all the elements which is in front of 3 including 3. So 2 elements are there including 3, so we will push 2. So as we need to perform 2 swaps, so we are pushing 2. Then now count will be, as we have pushed 2 inside it, so now the pointer will point to 4. Now 4 will be pointing to 3. As 3 is smaller, no swaps will be performed. It will be incremented to 5. Now 5 and 4 will be compared, as the element in earlier array is bigger than the element in the front array, next array, so one swap will be performed. So as you can see here, we got from right subtree we got 2 swaps, from left subtree we got from left subtree we got 2 swaps, from right subtree we got 0 swaps, and while merging them we got 2 plus 1, that is 3. Okay, so in total we got 5 swaps. Okay, so hope you understood this. Now let's see it in working. It is similar to merge sort code as I've already explained you earlier. Here I'm declaring an array, dynamic array, passing the number of elements which you want. uh, Here I am taking input from the user, what elements she wants. Initially it will start from 0, array will start from 0, and it will end at n minus 1. Now while merging them, array n start and end, I'm passing the parameter to the merge sort function. Now until what it will run, this is the base condition, this will run until start is greater than or equal to 0. That means even if one element is there in the array, we don't need to swap it, so, or we don't need to sort it, so we will simply return it. Okay, and we will initialize a count, then we will calculate the middle element, which would be start plus n by 2. Then we will see we will call the left tree, then we will call a recursion tree, we will call the left recursion tree, we will call the right recursion tree, and after we get the result we will merge them. This is the code of merging two sorted arrays. So this will perform, this will sort the left array and return the number of swaps being performed in that left array. So it will be stored in count. Initially the count will be 0. Now let swap will be added to this. After that the right tree will perform the operation, it will sort them and return the number of swaps being performed. Now the count will be added, 0 plus number of swaps in right subtree, plus number of swaps in left subtree. Then as we got two sorted arrays, now we need to merge them. While merging also we need to perform few swaps, so we will add the previous two results with this merge function. After adding it, we will return it to the earlier we will return this count to the earlier calling function, whichever it is. Okay, so this is about the merge sort function. Now let's see how the merge function will work. We are passing the array, the number of elements in the array, the middle element of the array, start and ending index of the array. I'll initialize the length of both the arrays. Length 1 will be mid minus start plus 1, length 2 will be end minus mid, which is very simple. Now I am initializing a pointer to those memory locations which will contain which will have a length of ln1 and length of len2. I am initializing a pointer which will point to the start initially. Count I'll initialize to 0, because each time it will call the merge function, the count has to be initialized to 0. Okay, so now I'm copying the elements from the array into our other created array 1 and array 2. After counting it, after replicating the elements in these arrays, then I'm checking whether there are elements present or not. Until the pointer is not going outside our len1 or len2, we are um, continuing with this loop. When we get an element bigger than the element in the second array, then it is the case that we need to swap it. So what we will do, we will increment the pointer pointing to the second array, and we will put that element inside our original array and increment the count by the number of elements which are present inside the first array which are ahead of it. So that's why I'm doing count plus len1 minus I. Okay, or else if the element in the first array is smaller than the element in the second array, so we will simply put the smaller element inside our array, and no need to increment the count. And this is a while loop in which if some elements from the first array is left, then we will simply push those elements inside the stack, and no need to increment the count because already the count has been uh, incremented over here. And if the elements in the second array are left, then we will simply put those elements inside our original array, and that's it. We will return this count. This count will be returned to the calling function, and in this way, at the end, when all the uh, functions in the recursive stack are over, this mod sort will return an integer which will be the total count or total swap that has been performed to our main function, and here we will print it. So let's see it's working. It is similar to merge sort program, just few changes are there. Now let's see. I'll take the same example which I've taken over here: 51324, 51324, 513, 2 and 4. Okay, so as you can see, 5 swaps we have performed over here, and here also we can see we got 5 swaps. Okay, so this is there is no error in the code, and it is showing right result. Let's try with one more example. Let's take 7 and give few elements to it. Okay, so 21 swaps are being performed over here. Okay, so hope your queries are solved. If you have any doubts, you can ask me in the comment section below. I will also upload this code along with the images, along with this image in my GitHub profile. So if you have any queries, ask me in the comment section. I will make another video if you have some doubt. Okay, so that's it for today. Thanks for watching, and bye bye.